up to our first speaker, Jeremy Keith, this year. Jeremy's many things. I've known him for quite a while. He's a web dev, he's an author, he's a mandolinist. His latest book is called Going Offline, all about service workers and how to get your websites working offline well. He works for ClearLeft, a company name he assures me was meant to be a much longer lasting reference, but nowadays is a little bit out of date. But his talk today will surely resound throughout the ages, in and out of style. Thanks so much, Jeremy.
Thank you, Tab. Thank you, and good morning. It is great to be here again after such a long break, talking to actual people rather than just talking to my screen. I don't have to ask, can everyone see my screen? You don't have to tell me, you're on mute. No, real life, it's good. And I've traveled to be here today. I've traveled from this place. This is Brighton, where I live on the south coast of England. Who's been to Brighton? Let's see a social. Nice. Oh, yeah. Then you know how nice it is. Something happened in Brighton in 1985. One of those places along the seafront was the venue for the International Information Theory Symposium. And something exciting happened there. A hubbub began to run through the event that there was an unexpected person attending. And that unexpected person was this man, Claude Shannon. The way it was described later was, somebody said it was like if Newton just showed up at a physics conference. That was the impact he had. He wasn't even meant to be speaking there. And he wasn't speaking. Except at the dinner afterwards, he was asked to, go on, say a few words. And he stood up and he was saying a few words, but he felt like he was losing the crowd. So he just started juggling, which is very Claude Shannon. He was a very playful kind of person, juggling, making toys and games. He made this machine, which is the most beautiful machine, also known as the most useless machine. I think it's kind of great. It's like the perfect encapsulation of cybernetics, human and machine in the perfect feedback loop. But that's not why people were excited that he was at the symposium. It wasn't because of the most beautiful machine. It wasn't because of its juggling. It was because of information theory. Because Claude Shannon wasn't just like a big deal in the world of information theory. Claude Shannon pretty much invented the field of information theory. And he did that in a 1948 paper called The Mathematical Theory of Communication. Here's the TLDR. This is the mathematical part. We won't dwell on that. But he introduced so many ideas in one fell swoop, like applying the concept of entropy from thermodynamics, applying that to information. This idea that you could distill information down into a fundamental particle that he called the bit. That was Claude Shannon. So, he's very much the father of the digital age because bits, ones and zeros, that's how computers work, right? And something else that I took away from Claude Shannon's work is the importance of context when it comes to communication. Shared context between the person transmitting a message and the person receiving a message. To illustrate what I mean, I'm gonna use an example that's probably apocryphal from a non-digital network, but equally revolutionary, the telegraph. And the way that this story goes is like in the 19th century, and there was an author. In some of the stories, it's Oscar Wilde. Somebody else says it's Victor Hugo. But anyway, this author has written a book, sent it to the publishers, and he's gone off on holiday for a well-earned rest. But while he's on holiday, he really wants to know how the book sales are going. So he telegraphs to his publisher. And because his publisher is kind of expecting this, they have this shared context, he can telegraph a single character. And so he telegraphs a question mark. And again, because there's this shared context between the writer and the publisher, and the book sales were going really, really well, the publisher also texted back a single character, an exclamation mark. So that's only possible, right, to send one single character and have it be understood because of the shared context that the author and the publisher had. So shared context is an important concept when it comes to communication theory. Now, I want to kind of test our shared context here. I'll run a little experiment. I'm going to start with a blank slate, and then I'm going to attempt to transmit information using visuals to you. I'm going to see how long it takes till you kind of get it. So here's the first bit of data. Okay, by itself, this probably doesn't tell you much. A diagonal line. Not much to go on. So back to the blank slate. Now I'm going to send you a second piece of data. It's another diagonal line. Again, not giving you too much, but once I combine those two pieces of data, maybe it's beginning to fall into place, and I'll provide one more piece of data, which is a circle. And now maybe you get the information I'm trying to transmit, which is, in this case, 10 minutes past 10 o'clock. If you can read an analog clock face, then we have a shared context. Yeah, I mean, if you're a digital native, then you're like, what's he talking about? It's two diagonal lines in a circle. But if you do know how to read a diagonal clock face, then we have that shared context. And I can just give you two diagonal lines in a circle, and you totally get that. Oh, right, it's 10 past 10. An arbitrary time, I should mention, other than the fact that if you ever look at an ad for a watch, it's always 10 past 10 because that frames the logo of the watchmaker. But anyway, so that's our shared context of how to read an analog clock face. But where did this come from? Clock faces. Like, why do clock faces go clockwise? Well, it seems like a fairly arbitrary decision. Well, one neat explanation is the reason why clocks go in a clockwise direction is that that's the direction that the shadow on a sundial would have moved in the northern hemisphere. Now, a sundial in the southern hemisphere, like this one, this is in Wellington in New Zealand, the shadow would move in a counterclockwise direction. So it's kind of an accident of history that clocks move in a clockwise direction. Had clocks been invented in the southern hemisphere, then we'd think it totally normal that clocks would go the other way. So it's an arbitrary thing, but we're totally stuck with it. We can't just change it, right? Because inertia is this very powerful force. The fact that we've done it this way, even if it's for an arbitrary reason, we're probably going to stick with doing it that way. You know, a very wise person once said, the most dangerous phrase in the English language is, we've always done it that way. And that very wise person was Rear Admiral Grace Hopper, the brilliant computer scientist, inventor of the compiler, amongst other things. And she was very aware of the power of inertia. She said, humans are allergic to change. I try to fight that. And she went on to say, that's why I have a clock on my wall that runs counterclockwise. And she did. And it's kind of weird to look at a clock that's counterclockwise, right? It's like you could understand it, but it takes some time. I actually managed to find a watch a few years ago that worked like this. And after wearing it for a while, I could totally just understand it and I could parse it. But it broke my brain for reading any other clocks, right? And I'm always fascinated by these stories of a fairly arbitrary decision that was made in the past that we're now stuck with today. It's ubiquitous. But only recently did I find out that there's a term for this. It's called path dependence, right? Arbitrary decision in the past ripples on down through time to today. Like the canonical example of path dependence is if you would like to make a new train or a new piece of railway track, you had better use the existing gauge of railway wherever you want to deploy that railway track or that train because otherwise it's just not going to get used. Now, it's not that any particular gauge of railway track is better or worse than any other gauge. It's just the fact that whatever people are using, that's what you need to stick with if you want to have any chance of adoption. Otherwise, people have to change trains every time there's a change of track because people are using all different gauges, which is actually what happened in Australia. And you want to avoid that. This is kind of like the canonical use case for standards. This is why standards matter, is that everyone's using the same thing. There's sometimes maybe a misunderstanding about standards, the idea that standards may be about getting to the best possible solution. But actually, well, that's a good goal to have. The real value in standards comes with agreement. The fact that everybody agrees to do things the same way, agrees on implementing something the same way. Like, driving on the left side of the road or the right-hand side of the road, it's a fairly arbitrary decision. And it kind of doesn't matter which one we do. But it really matters that we all agree which one we're doing at any one time, right? And talking about agreement brings us nicely to the World Wide Web. One of my favorite definitions of the World Wide Web comes from my friend Paul Downey, who does these wonderful illustrations, and he literally says, the web is agreement, right? He draws these fantastic, like, Hieronymus Bosch, Bruegel, like, illustrations of the web. But it's true. If you think about the original World Wide Web, it was created by Tim Berners-Lee, and it consisted of three things. It was HTTP, the protocol, URLs, right, for addressing, and HTML as a format. And these are agreements. Let's all agree to use this protocol. Let's agree to use this addressing scheme. Let's all agree to use this particular format. And these came from this man, Sir Tim Berners-Lee, and I'm really fascinated by the history of the web. And part of that is because I was really fortunate a few years ago to be invited to CERN when it was coming up to the 30th anniversary of the web. It was me and a bunch of these nerds here. We were involved in this kind of hack project, and you can see the results at this URL, worldwideweb30.com. What we were doing was reproducing the very first web browser built by Tim Berners-Lee. It was called World Wide Web, confusingly. And we're trying to recreate the experience of that in a modern browser, and that's what you can experience yourself. If you go to that URL, you can put in a modern URL, you can see how it'll be rendered in the very first web browser. This is the very first web page written in the very first web browser. Now, I say we were working on this. I didn't build this. I'm not clever enough to do that. That was the smart people, like Remy Sharp was doing that stuff. No, I was working on the website about the project where, like I say, I was really diving into the history. I spent most of my time working on this timeline built with HTML and CSS, and it's responsive, where I thought, well, it's the 30th anniversary of the web, and the obvious thing to do is look at 30 years of the web, what's happened in the past 30 years since that original proposal. But I thought it would be really interesting to also look at 30 years previously to that proposal. Like, what were the influences on Tim Berners-Lee? What were the path dependencies that Tim Berners-Lee had to work with when it came to hypertext and computing and formats? Like, talking of formats, if we look at these elements here, these should all be pretty familiar to you, right? You look at this and you say, oh, yeah, I know what this language is, right? Yeah. This language is SGML. Standard Generalized Markup Language. And this format was being used at CERN at the time. All these elements were already in existence, and Tim Berners-Lee just used it. He basically just took what was already there and built on that rather than creating a new format from scratch. Why? Because people are allergic to change, inertia. He knew that it would be easier to get adoption if you use a format that people were already familiar with. And that's what he did. I mean, even the name, you can kind of see the path dependency there. You can see, right? Oh, it was SGML, and now it's HTML. We have hypertext markup language, right? Seems pretty clear. It goes deeper. Here's the thing. SGML actually came from a previous format called GML, which was supposed to stand for Generalized Markup Language. Except the three people who created GML had the surnames Goldfarb, Mosher, and Laurie. And now I think we see the real reason why it was named GML. And so the reason why HTML is named HTML is because three dudes wanted to get their name into a format. But we're not here to talk about HTML. We're here to talk about styling. What about that original first web page and the first web browser? How did styling work? Because when you look at it, there's no CSS. CSS doesn't exist at this point, but there's styling. You can see there's some kind of formatting going on here, that the headlines and the paragraphs and the definition lists look different from one another. They are styled in some way. Well, when we were at CERN for this project, we had access to the original source code that Tim Berners-Lee had written for this web browser. And we were kind of spelunking down into the source code, and we found this file. And this is the file that declares how things should be styled. Okay, it's not CSS, but you could sort of, parse it. You're kind of squinting at it. Maybe it's like looking at a clock that runs counterclockwise, but you can sort of see what's going on. And pretty, it became clear very early on that it wasn't enough to just leave the styling to the browser, to the user agent, that the authors of the HTML would also need to provide some way of styling their HTML. And this got quite urgent as well, because what was happening was HTML was getting diluted with styling elements and attributes, things to, that affected how something looked, rather than described semantically what something was, which is real danger, because it was really important that there'd be the separation of concerns between, the semantics and the structure and the styling and other things. So very early on, people started to propose a way for authors to somehow style what they were putting out there on the web. In the early days of the web, it was literally like, a few people on a mailing list called www.talk, and pretty much all of them were making web browsers in the early days. So there's been a few proposals, and the earliest one that I could find came from Rob Raish, who was working at O'Reilly at the time. And he sent an email to www.talk on June 10th, 1993, with this proposal. It's not CSS, but it's also not CSS. Like, you can kind of figure this out, right? You get it. You get what's going on. Now, it's clear here that the priority was keeping things short and brief. Like, you see a lot of shorthand going on here. FO for font, FA for family or face, I guess, and SI for size. So you can say, okay, so it's a font family of Helvetica, HE, and a size of 18. And we've got, the concept of selectors with this @ syntax there. Fairly arbitrary, see? The next proposal I found was from Pei Wei, who was working on the Viola web browser. He sent his proposal in October of 1993, and he was able to fit his entire proposal, entire style sheet, into the email. It looks like this. And again, somewhat similar, equal signs instead of colons between properties and values, but we're getting the idea of the selectors here. Nesting, right away. We've got nesting here, decades ago, and that's something we're really only just getting in modern CSS now. So it's really interesting to see these ideas kind of percolate and come up again and again. The proposal after this was from 1994, October 1994, and came from Halcombe William Lee. And his proposal was called Cascading HTML Style Sheets. And here's an example of how that looked. And again, it's like, it's not CSS, but you can parse this like a clock running counterclockwise. Equal signs instead of colons. And we've got selectors and properties kind of munged together with this dot syntax, but kind of makes sense. I mean, actually, if you're a JavaScript coder, it makes a lot of sense, right? But you can understand what's being declared here, that the font size of H1 should be 24 points. But hang on, what's with these percentages at the end? What's with the 100% and the 40%? Well, this was a really, really interesting part of this proposal. It was the idea of influence. The idea that the author shouldn't have the final say over how something should look, but they should be able to declare how much they care. Like, 100% means like, I really want this to be 24 points, right? But if you're like, I don't know, 50%, I care 50%. And the idea is that you got, styles from the author, from the user agent, the browser itself, and each one would declare how much they care. And then there was some hand waving that said, and then the browser figures out the right styles to apply. So it turned out that hand waving was really, really, really hard. So that idea got dropped. But I actually think it's a super interesting idea of influence. Not just a very powerful idea, but a very empowering idea that, the relationship between the author and the user isn't just, I'm going to dictate to you the way things should look. And this idea of influence is very much in keeping with the early web. Like, that first web browser I showed you was not just a web browser. It was a web browser / editor. And Tim Berners-Lee felt very strongly that the web should be a read-write medium, that you're using your user agent to surf the web, but then when you've got a document in your web browser, that you should be able to go, I'm going to make a copy of this, I'm going to edit it, I'm going to make changes, and I'm going to put it on my web server, right? Turned out, again, that part was really, really hard. So that got dropped pretty early on, which is a shame because I think it's a very powerful idea. We've somewhat regained with things like blogging and wikis and even social media to some extent. I feel like influence and this idea of a read-write web, I like it. I mean, we used to have user style sheet, not user agent style sheets that the browser applies, but that the user themselves could have a style sheet associated with their browser that could be applied and would take precedence, would have influence over whatever was being displayed there. No browser has this today. You have to install a browser extension. And I get it. It was kind of a power feature, right? It was not something that was used widely, so I totally understand why browsers dropped it. But I think it was a really interesting idea. I'm kind of seeing a little bit of a resurgence of this idea of influence, this idea of the relationship between the author and the user in CSS today, particularly in media queries level 5, where we've got what are being known as preference queries, right? Where you can say prefers color scheme, prefers reduced motion, prefers reduced data. Now, it's not exactly like user style sheets because the web developer, the author, you still have to honor these preferences. You still have to write the CSS within these queries to respect what the user is declaring via their operating system. I'd prefer dark mode, please, or I'd prefer reduced motion, right? That said, some browsers are beginning to experiment with the idea of automatically applying some of these operating system level preferences like dark mode, reduced data, regardless of what the author of the website has declared. Speaking of modern CSS being foreshadowed in Howcome's original proposal, there's something else that he had in that proposal. You can see there, it's like, okay, I'm declaring the font size as 12 points, but that font.size is working kind of like a variable that then has calculations applied to it, right? It's being multiplied by certain. This is effectively custom properties and calc, which we now have in CSS, and I think are enormously powerful. I feel like we're only beginning to scratch the surface of what we can do with just those two things, custom properties and calc. But anyway, back to the proposals. The final one I want to mention was in 1994, and it came from Bert Buss. And this is what his proposal looked like. Again, kind of similar to what we've seen before, except now we're starting to see colons show up, right, instead of equals. Again, selectors and properties kind of munched together, but you can parse it. You squint at it and you're like, yeah, I see what's going on here. What I like about Bert's proposals, not so much the proposal itself, but what he also published was his set of design principles about all the things you kind of have to balance if you're creating a new standard, a new format. And I've got a real soft spot for design principles. In fact, I collect design principles. It's the equivalent of my interesting rock collection. At this URL, principles.adactio.com, I gather them together and just put them all in one place. And Bert's principles are well worth reading. The only thing is, there's a lot of them. These are all the design principles that Bert Buss is saying you've got to think about when you're creating a format, which is great. But I feel like what's missing from this is prioritization. Like, of these things, which is most important, which is second most, third most, and so on. I think that's where the real hard work with design principles happens, is figuring out what are the priorities out of these things. I feel like he's trying to balance all of them equally, which is really hard. But anyway, it became really clear that the proposal from Bert Buss and the proposal from Howcome and Lee were clearly on the same track, right? They were trying to solve the same problem. So they joined forces, and kids, that's where CSS comes from. And what they finally came up with together is this pattern. Selector, property, value. Couple of special characters, curly braces, fairly arbitrary, colons, arbitrary, semicolons, fairly arbitrary. But this is our shared context on the web when it comes to styling. And the fact that it all boils down to, this is pretty much all of CSS, right? Is selectors, properties, and values. And yet the possibilities are literally endless. You think of the number of websites out there, it's got to be billions at this point, the number of different style sheets, all of them are different, and yet all of them share this context. This is agreement. Right? We all agree to use this context, and the possibility to be, from this simple rule, we get a very, very complex system. I think this might also be at the heart of some of the misunderstandings about CSS. When people misunderstand CSS and think, oh, right, so CSS is easy. This is simple. Simple is not easy. So I kind of get where the misunderstanding comes from. Like, you can learn how CSS works in half an hour, because this is pretty much it. There's this thing called selectors, there's properties, there's values. But it could take a lifetime to even begin to master it because of all of the selectors and all of the properties and all of the values and how they all interact with one another. So CSS is simple, but CSS is not easy. And CSS has grown. It's grown over the decades, and yet still keeps to this one pattern at its heart, right? As we gain new selectors, new properties, new values. And it's grown by looking at, what are people trying to accomplish? So a lot of the growth came from hacks. And I don't mean CSS hacks in the literal sense of like the tan hack or the box model hack for those of you like me old enough to remember those things. No, I mean hack in the original sense of like a clever solution to a problem, but it's probably not scalable or sustainable, and you probably want to get rid of it at some point, right? That kind of a hack. So the classic example of hacking on the web in the early days was layout, right? Before we had CSS, we were using tables and HTML to lay things out. Spacer GIFs, right? 1 pixel by 1 pixel transparent GIF, and we'd give it a width and a height. These were hacks. They worked, but they were hacks. But later we got CSS. But we kind of just swapped one hack for another, because what we were using in CSS was floats, right? Floats and clears to lay things out. And that's not really what floats are meant for, right? Floats meant for, text wrapping around something like an image. And, for the longest time, there was a lot of debate about whether CSS was even the right place to solve the problem of layout. Like, you've got HTML for structure, you've got CSS for styling. Maybe there should be a third format for layout, which you can kind of see the argument for that. Now, as it turned out over time, it became pretty clear. Now, CSS is the logical place that layout lives as well. And that's where we have it today. Finally, we have proper non-hacky layout with Flexbox and with Grid. Although, this idea of it being in a separate format, we do kind of sequester our rules, right, into media queries generally. So it's kind of like having a separate layout technology in a way. But it's an example of the growth of CSS, looking at how people are hacking on stuff and then providing a standardized way to do it. It's the same story with typography. Like, if you wanted to use a specific typeface on the web, well, you went into Photoshop and you made an image using that typeface. And now the user had to download an image. It wasn't selectable. It wasn't accessible, right? It was a fixed width. It had all sorts of issues. But we came up with all very clever hacks to do what we called image replacement. But we don't need to do that now, because we have at FontFace, you can declare using a standard, I want that typeface, and it's the actual typeface. It's not an image of a typeface. Other places where we were hacking around, and I'm really going to start showing my age here as I describe this, is the little graphic design elements we wanted to do on the web. Okay, I'm going to air my dirty laundry here in public. This is a website I made in 2005 for my first book, which was called DOM Scripting. And you can see that, it's got this element with lovely rounded corners. And you see the background of the page there. It's got this gradient that goes from the top to the bottom. We didn't have rounded corners in CSS, and we didn't have gradients in CSS when I was making this website. So those 4 rounded corners, those are 4 images that have been absolutely positioned within that element. And that gradient is an image. It's a 1 pixel wide, but very, very tall image of a gradient that's then tiled across the whole background. But now we don't need to do that. Thank goodness we've got border radius, we got linear gradient. Ironically, right as we got these tools, so we could have all the rounded corners we wanted, and we could have all the gradients we wanted, we all collectively decided, nah, flat design. We just want flat colors, corners, rigid 90-degree angles. That's the future. Here's another website. This one's still going. This is my own personal website, adactio.com. And you can see that I've done some graphic design treatment. Now, it used to be I had to do this in Photoshop. See, I've sliced off a corner of that image up there, and I've added a gradient. This is what the original image would have looked like before I went into Photoshop and messed with it. Well, a little while back, I swapped out all that Photoshop messiness for CSS. So I'm going to use ClipPath to slice off the top of that image. I'm going to apply that linear gradient using generated content, right, with the after pseudo element. And the result is pretty much the same as if I had gone into Photoshop and just messed with the original image. But now it's in CSS. So what, right? Well, now that it's in CSS, the fact I can apply a dark mode, I don't need to swap out the image. I can change the styles. I can change the gradient, for example. But because it's being done in CSS rather than Photoshop, it's more native. It's a great example of what is called material honesty. which basically comes down to using the right tool for the job, or being, if you want to make something look like something else, don't use the material itself. Use CSS, don't use Photoshop. Grid and flexbox and border radius and font face, these are all examples of material honesty when it comes to building on the web. Where all those hacks we were using before, they were kind of materially dishonest. They were things pretending to be things they weren't. Also, it's just easier. It's so much easier to use @fontface or border radius than to go through all the hacks and loops we had to do with, image replacement and all those elements to do just rounded corners. So even those small things, it makes for a more materially honest web. It's a really recent, and I think great example of that is just things like checkboxes and radio buttons, styling those. Now, we have always been able to style them, but only with a bit of hackiness. I'll hide the original checkbox and display an image that looks like how I want it to look, right? Now I just use accent color. Mwah, I love it. So easy. I'm very lazy. So a solution like this, that's so much easier for me to do, I'm all about it. So there's been this movement from hacks to native CSS, native materially honest CSS. The other place where CSS has kind of found inspiration, I guess, or looking for direction of travel, is in the tools that we're using to create our CSS, to make our websites. A really good example of this would be Sass, an enormously popular preprocessor for CSS. Able to do nesting, able to do mix-ins, able to do variables, all the stuff that we couldn't do in CSS. And I think one of the genius things about Sass was the fact that it didn't feel like a separate format to CSS. The fact that it was familiar, right? It looked like CSS, led to its popularity in part, I think. In fact, I think Sass kind of took the same idea that Tim Berners-Lee had. Remember I was talking about how SGML was basically ripped off for HTML? I mean, you could literally take an SGML file and change the file extension, and it would be a valid HTML document. Well, Sass kind of worked the same way. You could take your existing CSS, change it to .scss, and now it was automatically valid Sass. And then you could begin to use the features of Sass piecemeal. You could start with little things if you wanted. This isn't just supposition on my part, by the way. This was kind of like an A/B test of this idea, because Sass actually permits two different file types, right? There's .sass and there's .scss, and they have different syntaxes. With the .sass syntax, it's all about significant white space. It gets rid of the curly braces altogether. Whereas with .scss, it's much more like CSS. We're stuck with the curly braces. Clearly, this is not as efficient. This is objectively more efficient and a better format if you are starting from scratch. But if you're already familiar with CSS, humans are allergic to change, then this is what you'll choose. And this is what people chose. Overwhelmingly, people chose the .scss syntax. Actually, so who here has used Sass at some point? Okay, this will be a pretty good test. So keep your hand up if you use the .scss syntax. And now raise your hand if you use the .sass syntax. I rest my case. There you go. You're a brave person back there. And I confirmed this. I was talking to Hampton Catlin, who created Sass, and he said, yeah, the numbers are wildly different. Everyone went for the .scss. It's a classic example of inertia, using what, you get better adoption if you use what people are used to. And Sass was this great testing ground for ideas that we can now do natively in CSS. We have variables in CSS now with custom properties. We can do our own mix-ins with calc. We have nesting in CSS, right? Thanks to Sass. It's a classic example of a tool, a framework, a library kind of pointing the way, showing we really want these features, make it happen. This happened in the JavaScript world as well, right? With jQuery. It's enormously popular as well. If you wanted to do DOM manipulation, you could use this DOM syntax. Or if you use jQuery, you could just use CSS. John Resig realized, well, people already know how to select things in CSS. Why are we making them learn a whole new syntax for selecting things in JavaScript? Let's build on that kind of path dependency there. And these days, you don't need to use jQuery because we have these features in regular JavaScript now. Query selector all, and you can pass in any CSS selector. But why do we not need jQuery today? Because of jQuery. Would we have even got these if it weren't for jQuery demonstrating there's a real need for this, that people want this? The popularity of jQuery pointed the way. So it was so successful, it's become obsolete. And I kind of think that's the mark of a really good library, a really good framework, a really good tool. It's become so successful that it's no longer needed because the standards themselves have made it obsolete. And you've seen this again and again over the history of the web with things like Sass and jQuery, and even Flash. Flash pointed the way. You know, animation, streaming video. We didn't have a way to do these things without Flash. So people used Flash to get the job done. But once we were able to do it natively, it was more materially honest. So these kind of tools and technologies are almost like R&D for the web. They're research and development for the web. Sort of like hacks. You could see these things as being hacks. I think a more generous reading is that these are polyfills. These are the things we use to kind of smooth over what the web can't yet do, and then we don't need them after a certain amount of time. There's other tools we've used for our CSS. I'm kind of fascinated by these kind of things. OOCSS from Nicole Sullivan, BAM, Smax was another one. There's a whole different, a whole range of these kind of things, but all of them kind of do the same thing. And what fascinates me is that none of these required lobbying of standards bodies or browser makers to say, hey, please implement this in browsers, because the technology was already in the browser. In fact, if anything, what these things do is they limit your possibilities. They constrain what you can do. They're a testament to the power of the cascade. These are all methodologies, right? Ways of working. Or another way to think about them is, these are all agreements. Let's agree to structure our CSS this way. And actually, another thing that fascinates me is that they're not really about CSS, they're about selectors. Like, none of these things care about what you do inside the curly braces. It's all about how we format things, how we agree to format things outside the curly braces. And generally, they're sort of trying to solve the same problem, which is the kind of the problem of scale. It's fine when you got one person working on a CSS file, but when you got a whole team of people, possibly distributed around the world, all trying to write CSS together, ooh, it can be tough, right? And why is that? Is there something in CSS itself that makes it hard to work and operate at scale? I love this tweet from Miriam, where she says, large companies find HTML and CSS frustrating at scale because the web is a fundamentally anti-capitalist mashup art experiment designed to give consumers all the power. I think it's brilliant. I mean, it's funny, but there's a hint of truth in that as well. And this idea of influence, who has the power? And the web does favor the user, the idea of the read or write web. So maybe when you look at all those design principles that Bert has trying to balance, maybe scale wasn't one of them. Maybe that wasn't what was a priority. It was more about empowering individuals. And I'm kind of okay with that. Anyway, we're solving this problem now in CSS because we're getting things like cascade layers and we're getting scope. And you'll be hearing more about that from Tab later in the conference. But this is almost like a resurgence of influence, but at a different level. It's about influence between multiple authors. Like, how much influence does this author get versus this third-party author versus the team over there? This could be really powerful. This could be a game changer for CSS. It's a very, very exciting time for CSS right now, as you're going to find out over the next 2 days. There's a lot to take in. I'm always fascinated by what's still missing. What are we still missing in CSS? Where are people still reaching for hacks or for tools to solve a problem that they can't yet do in CSS? Oh, this is also a great question to ask of JavaScript as well. Why are we still using a particular tool or framework or library rather than what the browsers natively give us? Well, I want to illustrate, maybe getting to an answer to this question, closing with 3 examples of 3 components and how you might approach them. The first component is a button component. Seems pretty straightforward. You want to make a button on the web, you got 2 options. You use a button element and you style it with CSS, Or you do this, you use divs and spans, and you style it with CSS, and then you add all the JavaScript to intercept the clicks, and then you have to add all the ARIA to make sure it's accessible too, right? I said I was lazy, so I'm going to do this every time. It's also just better, right? I mean, there's literally no reason to do this anymore. There was years ago, older versions of Internet Explorer, they made it hard to style buttons, but we are talking ancient history. So in this case, it's a very clear-cut answer to how to do a button component. What about a drop-down component? The user needs to select an item from a list of options. Well, again, you could use the native HTML elements, select, style it with CSS, or you just make it yourself with divs and spans and JavaScript and ARIA. But you start to run into some of the limits now because, yeah, I can actually style a select when it's closed. But the open state of a select. Now, me personally, I'm like, live with it. I'm going to use a select element. I'm lazy. It's better. It's more semantic. It's accessible. I'm going to do this. But I have to admit, if you really care about, styling that open state, I get it. I get why you would do this. The final component I want to mention is let's take a date picker. Oh, you know where this is going. The user selects a date from some kind of widget. Well, I'm lazy. I've got the easy option here. I'm going to use input type equals date. I'm going to style it. Yikes. If you've ever tried styling input type equals date, you know it's a world of pain. So here, I totally get it. I get why it's all divs and spans. It's probably a library, right, to do this stuff. It's kind of it's battle between the materially honest way of doing things and the hacks. But I understand why people are reaching for the hacks because we're just not quite there yet with some of these. It's like, this is the under-engineered example. This is the over-engineered example. And I would love it if we didn't need to do the over-engineered way, but I do kind of get it. I didn't used to get it. I used to be really militant about this. I'd be like, that's wrong. You shouldn't do that. You should always do this. I don't care if you can't style it, right? I used to get mad at people choosing the hacks. But it's like, that's like getting mad, trying to reduce teen pregnancy by telling people to stop having sex, right? Yeah, abstinence is not realistic. People are going to do it anyway. So the question is, how do we make it safer in the long term? And that is why I recommend you take a look at the work of openui.org. That's open-ui.org. Their mission statement is, the purpose of OpenUI to the web platform is to allow web developers to style and extend built-in web UI controls, such as select, checkboxes, radio buttons, and date and color pickers. Yes, this is the battleground. This is where we should be focusing our attention. I really recommend you get involved there. Give your use cases, feedback on proposals, heck, submit proposals, right? This is where we want to close the gap with what we still can't yet do in web browsers. And we should be using web browsers, right? Instead of shipping our own frameworks and libraries and solutions. Because the difference between doing something in the browser and doing something with a framework is context. A web browser is a shared context between users and authors. And if you want to use a framework or a library, you have to ship the context to the user. And that puts a burden on them in terms of performance, in terms of user experience. But web browsers are where past agreements live on today and into the future. Right? By using what's in web browsers, you're benefiting from decades of work by multitudes of people. And it's better for users. Treat frameworks and libraries like polyfills. Use them as a temporary measure when there's something that's still not possible in browsers. And this is very true of JavaScript frameworks. They can point the way to a shared context in the future, but they themselves are not the future. Don't get too attached. Treat them as cattle, not pets. Use frameworks and libraries as scaffolding to help you build, but they are not a foundation. Web standards in the browser are your foundation to build upon. And having an awareness of the history of the technologies, right, from sundials to web browsers, it can help you have an understanding of the way things are today. And in some ways, the lesson of path dependence is, it's kind of grim, right? Because of some arbitrary decision in the past, we're now stuck with the consequences in our clock faces, in our CSS, and it's really hard to change that. But there's another way to look at this. Nothing was inevitable, which means nothing is inevitable, except for entropy and the heat death of the universe. If someone tells you that's just the way things are, accept it, don't believe it. Understand your position in the timeline. Yes, the present moment is the result of decisions made in the past, many of those arbitrary decisions. But that also means the future will be hugely influenced by the decisions you make today, even if those decisions seem small and inconsequential. The choices you make now could have long-lasting repercussions into the future. So make your decisions wisely. You are literally creating the future. And I'm looking forward to seeing the results. Thank you.
All right, and we're going to do a little Q&A at the end of every session here. So I've got a couple of quick questions for you, Keith, or Jeremy. Sorry, you got two first names.
Yeah.
First of all, that was an incredible keynote. Very inspiring. I loved it.
Oh, thanks.
I loved seeing some of the love that you gave to technologies that I've worked on too. Always good.
Yeah, you've been in the trenches. You've been in the coal face.
Yeah. So you've mentioned a whole lot of different hacks that you've had to learn over the years, things that you've replaced, things that you've lost, things that have been improved on. What are you saddest to have had to learn in the first place?
I don't know about saddest, but like there was a lot of wasted bandwidth in my brain for table layout. I mean, we're going way back, but I used to pride myself that I could keep 3 levels of nested tables clear in my head. I wasn't using a design tool to do this. This was all in my brain. Mm-hmm. And I thought I was an awesome web designer because I could keep 3 levels of nested tables clear. Also, the waste of brain space.
3 levels of nested tables is the precise reason when I first started working on web dev that I decided I needed to throw all this out and rewrite the stupid website that I was working on. It was all to implement a list with colored bullets.
Yeah,
was the worst. You also mentioned in your talk a number of luminaries, a lot of great old names. Shannon, Hopper, Newton, Berners-Lee. Who do you think you are most similar to?
Oh. I think I'd like to be most similar to Claude Shannon because he's such a wacky guy, with juggling and his machines and stuff. But maybe I've only got the wackiness and none of the intelligence that enabled him to come up with information theory.
You need to actually be able to juggle first.
Yeah. So I'm clearly not like any of those people. I don't come close to any of them.
That's fair. You mentioned a couple things at the end that are not great to use now. What is the next thing that you would like us to pull out of existing tooling and libraries and make standardized?
All that stuff to make single-page apps. All of the reasons why people are using React and its ilk today. Actually, I should clarify. If you're using React as kind of like a tool to generate websites, in other words, it's sitting on your computer, your team uses React, but the output is, good old HTML, CSS, and JavaScript, great. That's absolutely fine. I'm talking about what gets shipped to end users and the pain that end users are experiencing by having to have the context of React. I'm using React as a catch-all term here. You know what I mean, right? Those kind of libraries. Just so that we can have a particular architecture for single-page apps, which frankly, I don't think we need that often either, but that's a whole nother thing. So I'm excited about some of the work that's been happening, things like element transitions, page transitions and stuff. I'm a little concerned though, because I know that the prototype, I saw Jake's talk about this idea of like doing stuff more easily, sharing how elements or pages transition from one to the other. And it's currently being prototyped for single-page apps, because that's the kind of easier one. And then it'll be multi-page apps, because that's what we call websites now, multi-page apps.
Yeah.
But I'm really worried that it'll get to we did it for single-page apps, and it's actually really hard to do for multi-page apps. I will leave it. Because then you're basically rewarding people for making single-page apps, and no, we want to be kind of doing the opposite. Yeah. So those kind of things.
Fair. I was actually working on the spec for the single page animation transitions literally the day before I left to come over here. So we're working on multi-page. It definitely is harder, but it's definitely happening.
Excellent.
That's just crossing document things safely.
Yep.
Very difficult. But all right. That's all for us today. Thank you very much, Jeremy. Let's do an applause. Yeah.